Hello, my name is Paul Llewellyn, General Sales Manager at Lubrication Engineers. I want to share with you today this brief presentation on how manufacturing plants can use lubrication reliability best practices to reduce energy consumption, reduce emissions, and reduce operating costs, all at the same time. This information is based on a white paper written by John Sander, Vice President of Technology at Lubrication Engineers. One way to reduce energy consumption is by upgrading plant equipment. Taking advantage of new, energy-efficient technologies can reduce energy costs. Another simple change you can make to create savings is improving the lubrication reliability program. Keep in mind that lubricant costs are minute compared to excess energy costs. Electric utility bills generally dwarf maintenance and lubricant costs. So, while controlling or reducing maintenance and lubricant costs is important, reducing electric utility usage is critical. Tremendous opportunities exist to use an improved lubrication reliability program to decrease your plant's energy costs. According to a recent report by ExxonMobil, energy usage per person varies dramatically around the world but averages 200,000 BTU per day, which is a total worldwide usage of 15 billion BTU per second. This same report points out that each person has direct and indirect energy demands. Direct demand of energy is the energy that drives our personal vehicles and operates our homes, while indirect demand is the energy that heats and cools buildings, generates power, produces goods and services, and provides mass transportation. As the lesser developed parts of the world modernize, their needs for energy will grow, resulting in an increased cost of fuel worldwide. Along with this, many of the world's governments are passing stricter environmental laws. These factors, combined with a struggling economy, result in a challenge for plant operation managers to reduce operating costs. Often, this means doing more with less. As consumers, we are aware that we use large amounts of energy, but we may not be aware of the different sources of energy that exist. Some of the various forms of energy include chemical, nuclear, radiant, thermal, sound, and electrical. Energy often transforms from one form to another for an end-use purpose. For example, oil, when combusted, contains chemical energy that converts to thermal energy, then to electrical energy or mechanical energy. During conversion from one form of energy to another, some usable energy is lost. These energy losses can be extremely costly to society. Here's where lubrication becomes important. The science of physics reveals that lubrication can play a role in reducing energy losses by reducing friction. Okay, you know that a lubricant can help reduce energy use, but will just any old lubricant do the job? You might think so if you've ever heard the statement, oil is oil, just pour it in. However, this is far from the truth. A lubricant is composed of a base fluid and additives. Many lubricant suppliers formulate their lubricants according to unique recipes intended for specific purposes. You can find oil specifically developed for passenger cars, heavy-duty diesel engines, and several other fleet-related needs. You also can find specialty lubricants formulated for the unique needs of compressors, bearings, gearboxes, wire ropes, and many other industrial applications. Within each lubricant type, there are various base fluid types and even more additive types. Each category has its strengths and weaknesses and should be chosen based upon the needs of the application type. These categories include mineral oil, containing a base fluid derived from refined crude oil, synthetic, containing a synthesized base fluid, rust and oxidation, containing rust and oxidation inhibiting additives, anti-wear, containing wear-reducing additives, extreme pressure, containing extreme pressure wear-reducing additives, multigrade, containing viscosity index improving additives, detergent inhibitors, containing detergent, dispersant, oxidation, wear, and anti-corrosion additives, and others such as defoamants, emulsifiers, demulsifiers, pour-point depressants, and thickeners. It becomes obvious that lubricant formulations can be rather complex. When searching for the best lubricant to minimize energy loss due to friction, it is often a case of you get what you pay for. In other words, an inexpensively priced lubricant does not necessarily provide maximum performance. It may require a higher amount of energy consumption and sometimes at a higher cost than with a more expensive, better performing lubricant. However, just buying an expensive lubricant does not ensure maximum lubricant performance and energy savings. The lubricant must be the right one for the application and must be properly maintained in order to provide maximum performance. This means proper storage and handling, filtration, oil analysis, educated personnel to handle and administer lubricants, and more. All electromechanical equipment requires periodic maintenance to operate at peak efficiency. Inadequate maintenance can increase energy consumption. It also can lead to high operating temperatures, poor moisture control, excessive contamination, and unsafe working environments. Depending on the equipment, maintenance may include the replacement of filters and fluids, inspections, adjustment, and repairs. So how does the end user know what to do? The answer is to find a lubrication partner who can help you develop a comprehensive lubrication reliability program that includes lubricant selection, protection, and maintenance. This partner could be a consultant, but it could also be a lubricant manufacturer that offers customized, comprehensive solutions, including performance lubricants and all the related reliability products to control contamination. You can measure energy savings in a variety of ways, including production output, temperature changes, or electrical reduction. Keeping track of production output helps you evaluate the equipment's energy efficiency. For example, if a machine is capable of producing a certain number of parts in a given amount of time, and the lubricant is changed, resulting in a higher volume of parts being produced in the same amount of time, then the machine has become more energy efficient. One must be careful when using this technique to ensure that nothing changed in the process except the lubricant. This can be overcome by using a larger number of test units or evaluating productivity over a longer amount of time. Monitoring temperature changes is another way to optimize lubrication program performance. Increased friction in a piece of moving equipment results in higher operating temperatures. Friction is a result of metal-to-metal contact that occurs between two opposing surfaces moving relative to one another. The greater the amount of contact, the greater the amount of friction. As a result, more energy is required to move the surfaces, resulting in higher electrical power costs. When friction is reduced, less electricity is required to drive a gearbox, compressor, pump, or other piece of equipment. To measure operating temperatures, the bulk oil can be monitored in a piece of operating equipment. Another technique is thermography, which involves using infrared detection equipment to look for so-called hot spots on a piece of equipment that could result from insufficient lubrication, improper lubricant selection, or faulty operating parts. In any of these cases, higher temperatures result in wasted energy. It is important, however, to account for ambient environmental temperatures when performing this type of study. Obviously, a piece of equipment will run hotter on hotter days than on cold days. A third way to measure energy consumption is by tracking electrical consumption. Tracking electrical consumption is a highly reliable way to evaluate improvements in plant energy use. In fact, various companies have been able to document improvements in electrical energy efficiency related to their lubrication programs. Typically, companies that upgrade their lubricants and reliability practices have been able to document a 5 to 15% reduction in power requirements, more than enough to pay for a better performing lubricant. Average documented savings were 15% in gearboxes, 12% in air compressors, and 4% in electric motors. In conclusion, there are a variety of reasons to reduce energy consumption, such as conserving natural resources, reducing emissions, and improving profitability. As the largest consumer of energy, industry is the greatest source of potential reductions. Energy use can be measured through production output, temperature changes, and electrical consumption. It is possible to make dramatic gains in energy efficiency by reducing friction. One of the best ways to do that is to employ good lubrication practices, including the use of high-performance lubricants and the adoption of lubrication reliability best practices. The key to success is finding a lubricant company that not only can provide the right high-performance lubricants for the applications, but also can recommend reliability solutions that will further reduce friction and maximize the efficiency of equipment. Thank you for taking the time to sit down with us today. We appreciate your interest. If you have any questions about improving your reliability practices, please contact Lubrication Engineers at 800-537-7683 or online at www.le-inc.com.